In Part 1, we looked at all the various filtering options available in the Monitoring Flows report. Part 2 was all about the default column headings in the results table and what they mean. Part 3 looked at the results of a search. And Part 4 covered the first part of the General tab within the Flow Details pop-up. In this last section, we'll look at the rest of the General tab details and the other tabs as well, starting with the Stats section. Outbound and inbound ratio relates to boost and the difference between data received on the LAN and data transmitted out on the WAN. With data reduction, you'd expect to see a positive ratio value anywhere from 1 upwards, with one exception. For encrypted traffic, if the EC cannot decrypt the flow, boosting it will actually add data to the payload, resulting in a ratio lower than 1. Outbound and inbound bytes. We'll use a diagram for this because it's a bit tricky to get your head around. Outbound is traffic arriving at the LAN interfaces and leaving via the WAN interfaces. Outbound LAN bytes is the total number of bytes received from the LAN heading for remote destinations via tunnels or internet breakout. This is before any boost, optimization, deduplication, compression has occurred. Outbound WAN bytes is the total number of bytes sent to the WAN after any boost has occurred. For boosted flows, this value would typically be less than the outbound LAN bytes value. Inbound is traffic arriving at the WAN interfaces and leaving via the LAN interfaces. Inbound LAN bytes is the total number of bytes sent to the LAN from remote destinations via tunnels or internet breakout. Inbound WAN bytes is the total number of bytes received from the WAN after any boost, optimization, deduplication, compression has occurred from the sending side. For boosted flows, this value would typically be less than the inbound LAN bytes value. The same directionality applies to the packet counters as well. Inbound WAN lost attempts to represent any lost tunnel packets relating to this flow. Note that this value may be non-zero, but FEC or POC packets may have been received to mitigate this. These counters are not intended for troubleshooting use. Inbound WAN average jitter is an attempt to calculate the delta in latency across the network path for this flow. Flow uptime is a calculation for how long has elapsed between the flow start time and the report being run. For an ended flow, this will be the flow's lifetime while active. Flow ID is its unique ID. Active is whether it's currently active or not. TCP flow context is sometimes used by our TAC team during troubleshooting. Is flow queued for reset? It's unlikely you'll see anything other than no here. Web proxy detected will report yes if a proxy connect request was seen during an HTTP or HTTPS session. Source and dest IP, yeah. Last policy change and lookup are internal IDs and not useful for troubleshooting. Okay, on to the QoS section next. Much like the root section, map name relates to the QoS policy map. Again, unless you're using scheduled maps, it'll probably be map 1 here. Priority in map. Similar to the root section, this is the rule number, and it should match the overlay matched. Traffic class configured is the number relating to the rule for the overlay. This will be the same value you see in config business intent overlays in the relevant overlays QoS, security and optimization section. LAN and WAN DSCP configured confirms the action in the rule, also present in the BIO config. Using stale map entry is the same as for the root section. It'll usually be no unless a new and different policy is being pushed at the time you're looking at the flow details. Then lastly, we see the DSCP markings as received from the LAN and WAN, but also as marked by the appliance, if trust isn't used in the policy. Also, we can see the first packet DSCP of the outgoing LAN and WAN packet and how that was marked. It's possible it may have changed during the flow's lifetime, and be different to LAN RX DSCP. Now let's cover the security section. This is much shorter and simply confirms if the flow was allowed or denied by the firewall or security policy. If it was denied, what the reason was, and the source and destination zones. There may also be a rule ID shown here. Lastly, the firewall protection section relates to the IPS-IDS feature set, and segments will give you some information about how the flow traversed the SD-WAN's segmentation feature, if applicable. The Internet tab can be useful to determine why a flow took a particular Internet path. You may see for Best Internet Link Choice Reason, in-house metric, which simply means it used an internal calculation to choose the best path with respect to latency loss and jitter. This is governed by the rank links by mode being set to auto in breakout traffic to Internet and cloud services in the BIO configuration. The App Perf tab is quite interesting. It provides information about network to server and client delays for TCP and UDP flows, which can be useful in performance troubleshooting. For example, if the CND is high, that would indicate a client on the LAN side with higher than usual latency between itself and the local EC LAN interface. This can cause buffers to fill and performance to be degraded, potentially for other clients as well. This value should be less than 1 millisecond usually. It can also help you identify where a performance bottleneck might be. For example, a server response time will usually be higher than the network to server delay. The application delay is a calculation of SRT minus SND. So if the application delay is quite a large number, you know the issue isn't with the network, but server-side processing. The client-to-server response delay is the sum of CND plus SND, but does not include application delay. The client packet retransmission count gives you an indication if there is any loss present. The TCP tab is a large topic on its own, and not typically used for troubleshooting, although TAC may request a screenshot of this tab from time to time. The AVC DNS tab may help with determining why a domain-based match did or did not get placed into the expected overlay. The results here are seen by the DNS and HTTP/HTTPS snooping processes. The other tabs are related to ClearPass integration. Hopefully this series of videos has given you a good insight into the flows table and the flow details output to help you understand your network traffic. That's all for this video. Thanks for watching.